Hello, my name is Professor Ajvan, and this is episode 7 of the Quadratic series. In this episode, we're going to be talking about factoring by grouping. This is a skill that we're going to be using in the next two episodes to factor different types of quadratics. These are the types of problems that we're going to be doing in this video, so if your homework problems look like this, then this is the correct video. If you are looking at these problems and you think that you already know how to do them, I would suggest going to the next episode in the quadratic series. For everybody else, let's go ahead and jump right into it. First of all, what is a factor? So if we think of some number like 12, a factor are just two numbers that can multiply to make 12. So an example of factors for 12 might be 1 and 12, could be 2 and 6, could be 3 and 4. So I could write factors of 12 as 3 times 4, 2 times 6, 1 times 12. And this is going to come in handy when we factor quadratics and polynomials. So if we take this polynomial, for example, and I want to factor it, meaning I want to end up with two parentheses that are being multiplied, some stuff inside these parentheses, and if I multiplied it out, I would end up with this polynomial. So the way we're going to do this with factoring by grouping, first of all, I want you to realize that there are four terms in this polynomial. If you see four terms in a polynomial, that's a good indicator that you're going to be factoring by grouping. And we want to make sure that the polynomial is in the correct order, meaning it is in algebraic descending order or standard form, where the highest degree is the first term and then it goes down by one, down by one, down by one. So once we make sure that it's in the correct order, what I want to do is cut it in half, meaning I want to just draw this imaginary line cutting our polynomial in half, and we're going to look at the left side and the right side of this separately. So if we're looking at the left side of this, x cubed minus 4x squared, what I want to do is factor out the greatest common factor between x cubed and negative 4x squared. If you're having trouble finding your greatest common factor, that was the previous video, episode 6, in the quadratic series, so go ahead and check that out. So looking at these two terms, we should be able to recognize that the greatest common factor between x cubed and negative 4x squared is going to be x squared. What are we left with after we factor out this greatest common factor of x squared? Well, from the x cubed term, we are left with an x, and from the negative 4x squared term, we are left with a negative 4. Alright, so we've factored the left side of this. Let's look at the right side. Let's look at the 3x minus 12. What is the greatest common factor between positive 3x and negative 12? Well, the greatest common factor would be 3. So if I pull out a 3, what am I left with? Well, the first term is going to be an x, and 3 times what gives me negative 12? 3 times negative 4 gives me negative 12. And this is why I really like factored by grouping, because if we look at this and this, the two pieces that we have left after we take out the GCF, they are identical. If they're identical, you know that you're doing this correctly. From here, we can, this is a plus, let me just be complete, it's a plus 3. We can look at this as being two terms. I have an x squared times x minus 4 as one term, and a 3 times x minus 4 as another term. I want to factor out this x minus 4 from these two terms, meaning I want to take it and put it in front. What am I left with if I factor out x minus 4 from both of these terms? Well, I would be left with this x squared, and I would be left with this 3. So just like that, we get our final answer looking like what we wanted to with the two parentheses. If we wanted to check our answer, which I recommend doing when you're first learning how to do this, we could FOIL this out and make sure that it is equivalent to the polynomial that we started with. Let's do another example. Let's look at 3x cubed plus 15x squared plus 2x plus 10. We're going to start this exactly the same way. Again, we recognize that there are 4 terms, which is our hint that we're going to be factoring by grouping. We're going to draw our imaginary line, and then we're going to look at the 2 terms on the left, 3x cubed and positive 15x squared, and ask ourselves, what's the greatest common factor there? We should recognize that the greatest common factor is 3x squared. And what are we left with? Well, from the first term, we are left with an x, and from the second term, we are left with a positive 5. If we go to the right side, where we have 2x plus 10, what is the greatest common factor? The greatest common factor is a positive 2, and we are left with an x plus 5. Just like last time, we can double check these two parentheses are exactly the same. So I'm going to kind of shortcut now. Once we identify that these two are exactly the same, what is in our two parentheses is one of the two factors, x plus 5. The things that we took out, the GCFs, the 3x squared and the positive 2, that is the other factor for our polynomial. And of course, we could check our answer by foiling or multiplying this using the box method or the stacking method, whichever method you prefer, and making sure that it's equivalent to the polynomial that we started with. Let's look at one final example. Again, 4 terms. That's our hint, factored by grouping. And we cut it in half, an imaginary line. And we look at our left side, 7x cubed minus 3x squared. What's the greatest common factor? Well, just an x squared, because there's no greatest common factor between 7 and 3. And what are we left with? Well, we're left with a 7x from the first term and a negative 3 from the second term. If we look at the right side, what's the greatest common factor between negative 77x and positive 33? We can take an 11 out of both of these, a positive 11. And what are we left with? Well, we would be left with a negative 7x plus 3. Are these two the same? They have the same numbers, but the signs on both of the terms, the 7x, negative 3, positive 3, they're different. So we have to do something. I need to not factor out a positive 11. What I need to do is factor out a negative 11, because we know from previous episodes that if we factor out a negative, it will just flip the signs of the polynomial on the inside. So that becomes a positive 7x, and that becomes a negative 3. So now that this 7x minus 3 and this 7x minus 3 are the same, that is one of our two factors. And then the two things that we pulled out, the two GCFs, x squared and negative 11, they make up the other factor. And again, feel free to FOIL this out, multiply using the box method or the stacking method from previous episodes to double check and make sure that what you get is equivalent to the polynomial that you started with. But that's it. That's factored by grouping. So what we're going to look at in the next couple of episodes is factoring quadratics specifically, and we're going to use this idea of factored by grouping to help us. If you found this video helpful, consider giving it a like and consider subscribing for more math lessons. If you have a question, go ahead and comment it below and I'll do my best to be down there and answering any questions that you may have. If you have a suggestion for a math topic that you would like me to cover in a future video, go ahead and comment that too. Thanks, and I will see you in the next one.